So, final exam. Let's be sure we're clear on all that. It's all we got left, right? The final. Final exam. When's our final?
Tuesday.
It is Tuesday. Normal class time, 11 to 1, huh? 2 hours, we'll take the final. There's no class Thursday. We just come Tuesday for the final, and we are done. And my office hours, if you want to get help, I'm glad to help you. Please come see me. Monday, 9 to 11. Tuesday, the hour before. That was for you guys in particular. Wednesdays after, so you probably don't really care. And Thursday. And I'm in, where am I at? In Math, Science, Engineering, room 5. And for the final, you get one full sheet of notes, right? Both sides. Write anything you want on both sides of a full sheet of notes. And what else? It'll replace your low score, right? Final will count double. Well, I won't write that down. I've said it a million times. So the final counts double and will replace your lowest score, right? So it'll be the final, and it'll replace your lowest score. Unless the final is your lowest, then it'll just be the final. But probably for most people, it'll count double, 200, as itself and as a replacement for your lowest other exam score. Make sense? Questions on the final or wrapping up the course? Yeah, everything? Yeah, so I'll post the keys by today, by 5 p.m. today. I will put on mathexcel.com the answer keys for exams 1 to 4, all of them. I'll put it right underneath announcements, like where you find the practice exams right now. Announcements. I'll put all 4 of them. You'll have the answers for both versions, A and B, so there'll be 8 of them actually. So you'll have all the answers there, so you can study off those and the practice exams. And you've got my YouTube reviews, right? I mean, the YouTubes on the review exams. That'd be a great place to go, right? You know what I mean? You can use those YouTube reviews, which go over the practice exams. I'm going to put the answer keys for all the regular exams up. So, yeah, because sometimes that's more helpful than YouTube. Whereas when I put the answer keys up, it's just going to be the answers. I don't do all the steps all the time because I'm really just doing it for myself to grade. So I'll skip a lot of steps. So I'm not really, it's not like the practice exams where I write out every little detail because I'm doing that for you. So you might prefer the practice exams. You might look at those answer keys and go, well, how do you get there? So just letting you know ahead of time. They might not be the savior of your life. You might prefer the practice exams and the reviews when I talk you through everything. Anyway, do whatever you need. Are there any questions on the final? Any other questions on how that's going to work? So you know right where you're at right now, right? The grades are up and all is good. All right. Do we finish up that last section? Do we not? That's not the answer I want. Let's try again. Did we finish up that last section? We did it. Oh, shoot. Okay. Okay. So here we are. So they're giving us a part of a triangle. Excuse me. So they're giving us a part of a triangle there, and they want us to find B, alpha, and beta. So, how do we do that? Let me give you a minute. I think you'll get more out of it rather than me just diving in and cranking it out real quick. Start with little b. How can you find little b? Little b means the side, right? Not the angle, right? So I want you to find the side here. So how are you going to find little b? Pythagorean would be a good idea, right? A squared plus b squared is c squared, because we know a is 1, and we know c is 5, and we want to find b, right? So 1 squared plus b squared is 5 squared. Let's do a little Pythagorean. That's easy, right? 1 plus b squared is 25. Subtract 1 from both sides. B squared is 24. Root it. Root it. B is the root of 24. Fine with me. Just leave it root 24. You don't need to make it whatever it is, 2 root 6 or whatever. So root 24. Good to there so far? Now, that one's good. Now, so next, and then they say find alpha. The next question is going to be find angle alpha, which is this one right here. So they want you to find that angle alpha. So let me give, that's the new part. So the B, that was no big deal. But find alpha. Let me give you a second there. See if you can find that angle alpha. Notice we don't know, we only know the 90-degree angle. We don't know alpha or beta, huh? So that's why this is different than those last ones. So how do you do it? Anybody got an idea? Can you do some trig relationships? Yeah, there's all kinds of Triggs relationships you could do. Like I'll just do sine, for example. So sine of alpha. So sine, remember what sine is? Opposite over hypotenuse, right? Remember the SOHCAHTOA? SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine, opposite over hypotenuse. So what's opposite of the alpha is 1 over the hypotenuse, which is 5. So sine of alpha is 1/5. Good so far? Sine of alpha, opposite over hypotenuse, 1 over 5. But, so how do I find alpha then? What's alpha? Sine inverse. Yeah, is everybody good with that? Can I do the sine inverse? Alpha then will be the sine inverse of 1/5. Right? Because alpha is the angle whose sine is 1/5. So sine inverse of 1/5. That's how you find angles when you don't know them like that. So sine inverse of 1/5. Somebody got that in their calculator? Make sure you're in degree mode. Anybody? Good, yeah, 11.54 degrees. So they want round to the nearest, 2 places, so there we go. 11.54 degrees. That good for alpha? That makes sense how I'm finding that? And now, how do I find, so then the last thing they're going to ask me, is that okay? Am I confused on that? The last thing they're going to say is, now find angle beta. So if I know that alpha is right here, 11.54 degrees, how can I find beta? Yeah, alpha and beta have to make 90, don't they? Because remember there's 180 in a triangle? It's 180 degrees in a triangle, and I already know this one's 90. I already got a 90, a right angle, 90. So the other two have to make 90 to make the total 180 in that triangle. So the other two are totally 90. So if I take 90 degrees minus the 11.54, I'll get beta, which is 78.46, right? Degrees is beta. And we're done. We got everything they wanted. We got all the angles, all the sides. Is that okay? Remember that kind of thing? I think you probably could have done that before this class started. You already knew how to do those triangle trig things, right? Or maybe sort of remembered. Good there? We okay? All right, flash off of that. Pretty easy, I think, for most people. Okay, so right triangle. I'll draw a little right triangle. Hypotenuse is 6 inches. Which side's the hypotenuse? The longest, the diagonal one, the one across from the right angle. Hypotenuse is 6. One angle is 43. I don't know which one. I'll just put it down here. You can put it in the other spot. It doesn't matter. One angle is 43. Find the two legs. Legs mean these two sides, right? This and this. Call it X and Y or Joe and Tom. You know, just names. I'll just call this X and this Y. So we got to find X and find Y. That's what they want me to do. So give it a try. See what kind of trig relationship you can come up with to find X and find Y. Okay, so what, let's start with X. So what trig relationship connects 43 degrees with the X and the 6? You see why I want them? Because I don't want to do the Y and the X at the same time, because that'd be two variables, which I couldn't solve for, right? So just one variable at a time, one letter at a time. So the angle, the variable, and the 6, because that way I have a number, right? So what trig relationship connects the 43 with the X and the 6? Cosine, huh? Because cosine, remember, is adjacent. The SOHCAHTOA thing. So, whoops, that's not the right SOHCA. I never actually learned it by SOHCAHTOA, but anyway, I'm writing it for your benefit. SOHCAHTOA. So, right, so cosine is adjacent over hypotenuse. Now, are you okay with that adjacent? Adjacent just means next to you, like your neighbors live adjacent to you. It just means next to you. So when you're at 43, X is adjacent. The Y is across, but the X is adjacent. And the 6 is hypotenuse, right? So adjacent X over hypotenuse 6, yeah. So the cosine of 43 degrees is X over 6, isn't it? That makes sense there. So we can solve that for X. So what do we do to solve for X? Just multiply both sides by 6. And this will cancel. And X will be 6 cos of 43. Somebody have that in their calculator? Should be about, I don't know, a little over 3, I think. 3 something.
There's a lot of allergens in there. You have allergies?
Yeah, I guess so. So 4.388 or 4.39 they want me to round. Thank you. So X is 4.39. So we got X. And now how do we get Y? You could. The problem is, if you're gonna use the Pythagorean, you're gonna use this 4.39. You're gonna use a rounded number. It's a little dangerous to use a rounded number to do another calculation because it's rounded, right? It's off a little bit. It could throw your final answer off. It's fine as long as you just use more digits than you're gonna need in your final thing. So how about, was it 388? I'll just use a couple more digits. 388. Yeah, because they're just saying 10, just one spot. So if I use 2 more, that should be good enough. And that should do it. So yeah, if you want to do Pythagorean, we can do that. X squared plus Y squared is 6 squared, right? So the X is 4.388 squared plus Y squared is what, 36? So as long as you use a couple more digits of accuracy than what you're going to need in the end, it'll be okay. Also, I could have just done sine of 43 degrees, huh? Sine of 43 would be Y over 6. That'd work also. Either way. Either way is totally good. So can I just go dot, dot, dot? You guys can finish it from there, right? And get Y, and then it'll ask for the shorter one and the longer one, the X and the Y. Good? Questions on that? No questions? We all good? All is well? All right, so there we go. Headed towards a plateau, 60 meters high. What are they talking about? So it's like you're walking on level ground, And up ahead, there's this plateau, right? A plateau means a flat area, but it's higher up, right? It's a flat area 60 meters high. So you're over here walking. You're walking, and you're looking at this plateau 60 meters high. The angle of elevation to the top of the plateau is 20 degrees. That means from where you're at to the top right here is 20 degrees. That's the angle of elevation. Not making sense to that point, right? Plateau is a flat area, 60 meters high. Angle of elevation always means you'll do a lot of that in calculus, Calc 1, you'll do these word problems and all that stuff. So angle of elevation means from the horizontal, right? So there's flat, horizontal, and then how much you elevate up from there, right? Flat, and then how much you elevate up. That's the angle of elevation, means from the flat, from the horizontal, how much up to where you're sighting. Remember those instruments where you can look through, and you can hold the bottom flat, and then you rotate it up, and you look through, it's called a sextant. You look through it, and it spots the top of a mountain or the top of a light post or whatever, right? It measures the angle. You can actually do that, right? Now, they use lasers and stuff, surveyors do. But before all the lasers, that's what everybody used, was the sextant, and they would do angles that way. They would look up, and it would, once you spotted the thing, then you would look back at your little instrument, it would show you the angle that you're at. So that's what they're saying, angle of 20 degrees. Okay, so what's their question? How far are you from the base of the plateau? No, there's X right there. I want to know how far we are from the bottom, the base of the plateau. So we're assuming this is a right angle here. So how can we find X? How can we find how far we are? Asymptote, they're handing you the thing back there. Behind you, they're handing you the... Everybody get the keys? Who wants the keys? They making it around?
I needed the key on this here.
Which color are you?
I'm blue.
So you need yellow.
Thank you. I believe I'm blue.
Anyway.
Thank you.
All right, so how can we solve for X there? What trig relationship connects the 20, the X, and the 60? Tangent, huh? Tangent. Tangent of 20 is 60 over X, because it's opposite over adjacent. So katoa, right? Toa. That's good. 60 over X. Tangent. Can you solve for X there? A lot of people mess up on that. Let me give you a second. I think it's worth your while. Solve that for X. Make sure that you can do that. It's a little tricky when X is on the bottom like that. Do that okay. So a common mistake I see a lot is students will go, well, you just divide by the 60. They'll just, this goes just tangent 20 over 60, that's X. That's not right, right? Because that X is in the denominator. We can't just get rid of that 60 and pretend all is well. That X is in the denominator. We got to get it out of the denominator. So what you got to do is put it over 1 and put the tangent over 1 and cross multiply, right? Diagonal, diagonal. X tan 20. Or you can just multiply both sides by X. Same thing. Either way. Is that making sense? So X tan 20. 1 times 60, 60. How do you solve for X? Divide by tan 20. Like that. Calculators, let me get it. What's 60 over tan 20? Oh, there it is. 164 point, how many places they want? 2 places. 4 rounds to 8.5 meters. That's how far away we are. So you can actually use that to figure out how far away you are from some kind of plateau thing. Or vice versa. If you know how far away you are, you can figure out the height of something that you can't climb. Right? They use that to find heights of things. In fact, I had, it was like, 4, 5, probably 5, maybe 6. Years are always passing faster than I think. Anyways, it was probably 6 years ago. I was teaching summer school, got back to my office here on campus, and there was a phone message flashing, so I played the message, and it just started off, hello, Brett, use my first name, hello, Brett, this is Hank, I only remember it was Hank Jones or whatever, I don't remember the name. Hello, Brett, this is Hank Jones, I'm out here on a job, and we need to tear down this big tree, where we're calling out some equipment to tear down this big tree, and I don't know if I should call the medium truck or the large truck. If the tree's under 100 feet, then the medium will do it, but if it's over 100, we need the large one. And I'm about 100 yards from the tree, and I'm doing my sextant. I've got the angles about 35 degrees, and I can't remember the trigonometry to figure out how tall that tree is. Right? They didn't want to climb the tree. They're trying to estimate the height of the tree. So Brett, can you give me a call back? Let me know. Here's my number. How tall that tree is. I heard that message, and I went, Hank, or whatever the name was. Hank Jones? Hank Jones. I don't remember Hank Jones. I remember thinking for a few minutes, no, I don't remember Hank Jones. But I don't have the greatest memory. So I just called him back, and got on the phone right. I said, hi, this is Brett Heron from Fresno City College. And he said, oh, yeah, Brett, thanks for calling me back. I got this tree, and da-da-da. I said, hold on, just a second, Hank. Just a second. I said, I'm sorry, but I just don't remember where I know you from. I was using my first name and everything. He's like, oh, you don't know me? You don't know me? He said, I just have this guy. I said, well, how'd you get my number? He said, I just called Fresno City College. He said, I had a math problem I need to figure out. I thought, I'll just call Fresno City College and ask for a math teacher. And they put me in head. I was like, really? I thought, well, we're a community college. We're supposed to serve the community. I said, sure, give me the numbers. I worked that problem and told him the answer. And it was kind of funny. It just kept using my first name. I said, do I know you? Anyway. All right, so sometimes you might get a call and need to know. Maybe not. Maybe you will. So there it is. So you can do that, figure out the height of things or the distance. Good on that? Questions? All right, back to talking and thinking about the final exam. So what I was going to do was just crank over some of your old exams. I thought that might be the most useful thing to do with our time. So like I said, I'm going to put the answer keys up tonight for the old exams. And I'll just start. I got them all with me. Anybody else need the key? It'd be the blue. The yellow is the blue, the blue is the yellow. Anybody want to see it? Well, they're up here. Feel to grab if you want to see it. So I'm going to start with exam 1. Would that be the best way to go? Oh, man, I don't know. Maybe I should start with exam 3 or 4 or something. What would be best? Which one did you guys like the least? Exam 3, maybe. 2 was 2 the worst? I can do 2. All right, I can do 2. 2, maybe 2 and 3. I don't know. The class did do bad on 2 as a whole. That's true. You guys aced 1, I remember. So I could do exam 2. So here's exam 2A, part 1. Let's just crank through 2A. And we'll do some of that. We'll do some of exam 3. How about I'll do some exam 2 and exam 3. All right. So 2A, part 1. Here we go. I'm just going to jump around and do the hardest things. So f of x equals 3 minus 2 to the x minus 1. They want you to graph it. Find the center point on the screen there, yeah, and one other point. Find the center point and one other point. All right, so let's see what you remember. Remember, so the final exam, which we take Tuesday, we'll have part 1, part 2. Part 1's again no calculator. Did I already say that? Final exam, part 1. Be clear. Final part 1, no calculator at all again, just like the last exam. No calculator at all. It'll have about 10 problems, I think. 10 problems. Probably 4 of them will be trig. Probably 6 of them will be graphs. I don't know. That's probably exaggeration. Probably 4 graphs. 4 graphs and 2 other, which I don't know. And then part 2 is using graphic calculator. But I want you to know, you're going to have a big part 1 with no calculator at all. Make sure you can add, subtract, multiply, and divide by hand, right? I assume you can. And so there'll be 4 trig questions and about 4 graphs probably. on the no graphing calculator. In fact, no calculator at all, right, on part 1, and 2 other things, and then part 2 will be using your graphing calculator, and everything else will be on there. Make sense on that? So can you do this one with no, this would be on the no calculator at all, is my point, because it's graphing, right? So can you graph that? So something needs to hit you right away when you look. You know, a lot of getting ready for a final exam in a math class or science class, I think is the same thing. It's identification, especially, 18 weeks. We've covered, it's been a long time. Seasons have changed, right? A lot has happened in 18 weeks. So it's a lot to remember. So a lot of it's identification. When you look at that, the type needs to jump off the page for you. You need to say, oh, that's a boom type. What type is it? What's the unique? Well, every problem has a certain category. You need to really, almost more than the details of step 1, step 2, step 3, well, probably equally important, is identification. You should practice that. Look back at the exam and just look at the beginning of the problem and go, would I know the first step? Just would I know how to start? Oh, that's what is that? What's unique on that one? This is what needs to jump out at you. X in the power zone. What's that called when you have a function with x in the power zone? Exponential. Exponential. Yeah, and that's a big deal in calculus. Because exponential functions, their derivatives are totally different. All their rules, derivatives, integrals, everything you do with them is different than not. What do I mean? Well, what I mean is this. If I had 4x to the third minus 2x squared, blah, 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 this is not exponential. So when I say exponential, I want to be clear. I don't just mean exponents. I mean x itself climbed into power. See that difference? This is exponential because not just that it has exponents or powers, but it has x up in the exponent zone, right? That's an exponential function. This would just be a polynomial, right? We just call that a polynomial. It's not a big deal. The rules are simple. But exponential, that's a whole different animal. It's a whole different category of function. So, all right. So that's the thing that needs to jump out at you. You need to look at that and go, oh, exponential. X is in power. We have special things we do for exponential functions. For the graph of an exponential, I can't talk and spell. I can't spell a lot anyway. Graph of exponential. The first step is the horizontal asymptote line. They always have one of those. They have a horizontal asymptote line. So what's the horizontal asymptote line? On this one. Where do you find it? It's the number added, subtracted to the front. In this case, it's the 3. So that's the horizontal asymptote, the 3. So when it comes to graphing this thing, let me go over here and graph it. That's the first thing you want to start with, is that 1, 2, 3. Horizontal asymptote line up at 3. Everybody with me on that? Is that coming back? Did you remember that perfectly before I said it? Probably not. It's been a long time, huh? So you definitely need to review for a math final. So there it is, horizontal asymptote of 3. Okay, that good? And then the second thing is more like the normal stuff we always do for graphing. Where we make the XY table and we find the center. The center point and then one other point. Remember all that? So let me let you try that. Find the center point and one other point. Now, what do I mean by the center point? How do we, more importantly, how do we find the center point? It's what makes the x zone 0, yeah, right? Right? So the center on any of these graphs, not just exponential, any of them, what makes the x zone equal 0? Now, what do I mean by the x zone? I mean the little world that x is in. For example, if somebody gives me y equals 7 square root of x minus 2 plus 5 or whatever, I would say x equals positive 2 is what will make x's little zone. The zone in this case would be the root, right? In our case, in our problem, the zone is the power zone where x lives, huh? So what can you plug in for x there that will make that zone 0? X equals positive 1 makes the zone equal 0. Is that good? Positive. So that's the center. X equals positive 1. So you plug in for x, whatever will make that little zone equal 0. So try that. I'm going to have to blow my nose. I'm having a nose problem today. So try that. So you plug in 1. What do you get when you plug in 1? I kind of run out of room here, huh? So when you plug in 1, you get y equals 3 minus 2 to the 1 minus 1, which is 3 minus 2 to the 0. What's anything to the 0 power? 1. That's 3 minus 1 is 2. Is that good? Over 1 up 2? Over 1 up 2. There, that dot right there is the center dot. I'll put C by him. He's the center. Okay, then for the other, you always just add 1, huh? You add 1 to whatever your center number was. So plug in 2. So 3 minus 2 to the, what is it? 2 minus 1. 3 minus 2 to the 1. 3 minus 2. 1. So 1 over, what is that? Over 2 up 1. There's the other dot. So we got the center dot and the other dot. Good to there. Now, can you, from those two dots and that horizontal asymptote line, can you get a form of the graph? Well, horizontal asymptote is a line of approach. Remember exponential graphs? They either rocket up or rocket down. That's what, the news says. Da-da-da is growing exponentially. They mean rocketing up super fast, right? So exponential graphs always rocket up or rocket down. It can't rocket up because it's got a horizontal asymptote line. So it must rocket down. See how I know that? Right? Because it's that horizontal asymptote line is going to be a line of approach, right? So I know it's going to go like this when it goes to the left. It can't bust through that line. That's a guideline, right? It's going to flatten out at that line. So therefore, it must rocket down the other side. Good? There's our graph. So definitely put that on. That'd be a good one. I'm just going to hit the main ones, that you need to put on your sheet for the final. This would be a very good one to put on your sheet, right? Horizontal, there's going to be one exponential graph, I'm sure. So you got to find the horizontal asymptote first, then your two dots. Good? Questions? All right, let's keep going. That was number 3 or whatever. So here's number, we could do number 4. Again, this is, what am I doing? Exam 2A, part 1. So let me put that up here. 2A, part 1, question 4. F of x equals minus x, x minus 2, x plus 4 squared. It says, give a rough graph. And find the zeros and the end behavior. Okay, let me give you a second. How much do you remember about all of that? Can you find the zeros? For starters, what are the zeros of that function? Can you just nail them off? Can you just glance at it and know them immediately, I'm hoping? What are the zeros? What is a zero anyway? What does that mean, a zero? What makes f equal 0? And f is the same as y, right? So what values of x, what could you plug in here, what could you plug in there, what could you plug in there that would make them 0? So 0 for the first one, positive 2 for that one, and negative 4 for that one, right? 0, positive 2, negative 4. We good there for starters? Right, because those three things are multiplied together. The x alone, the x minus 2, and the x, they're multiplied. So if you make any one of them 0, since they're all multiplied, the whole thing is 0, right? The whole function is 0. So those are our zeros. So that means on a graph at negative 4, at 0, and at positive 2, we're going to be at a height of 0. The function, and function values are y values, the y height is 0 at those three locations. Is that good? And nowhere else. Nowhere else will that graph hit the x-axis. Nowhere else will that graph have a height to 0, except those three. Okay, now what we need to know from there is the end behavior. Like, what does it do way off to it? Does it go way up or way down at the end of the graph? What tells you that? How do you know? Yeah, it's all about the most powerful term if you were to FOIL all this out. If I was to FOIL all of that out, I'm not going to do it all, but I can do just the front term, right? Because if I just grab the most powerful term in each multiplication, that'll be the overall most powerful term if I was to FOIL it all out. So this guy will multiply both those, but this times this will be much higher, right? And that's a minus x. And then times this guy squared. You with me? If I FOILed all that out, I would have minus x times x squared minus x to the fourth. So the end behavior is minus x to the fourth. So is that up or down? What is that? Minus x to the fourth? It's down, right? And the minus is down. So that one's going down. That one's going down. So let's get rid of this up thing. That one's going down. Minus x to the fourth. See that? You guys okay with that? I just FOILed this out. Just got the most powerful term. Okay, so it's going down. Now, remember the next thing is coming back a little bit? Remember this? It's been a couple months, or a month and a half. So we got to figure out if each of these guys are bouncers or passers through. Do we bounce when it hits these different dots, or do we slip through, pass through? What determines that? Exponent. What about the exponent? Even or odd. Even or odd. Remember, even powers bounce, don't they? Odd powers pass through, don't they? Remember that? So you just look at them one at a time, and you say, all right, let's look at the powers here. They're going to be messed. It's all messed up. So what was it? Minus x, x plus 2, x minus 2, x plus 4 squared. So look at the powers and decide. So the first one has a 1 power, and the last one has a 2. So the odd ones will pass through. So the first two are odd. So this one is x is 0. This one is positive 2. So at x is 0, that's a pass through. At x is positive 2, that's a 1 power. That's a pass through. At x is negative 4, that's even. That's a bouncer. Negative 4 is a bouncer. See how I figured that out? So 2 passers through, 1 bouncer, right? So as the graph comes here, it's going to pass through, bounce. There we go. There's a rough graph. That's kind of powerful, right? That quick. How long did that take us? Just by glancing at the zeros, pass through or bounce, in behavior, boom. So for example, if you were dealing with this function in calculus, I have a lot of flickering today. If we were dealing with this function in calculus, and you were going to, in calculus, you'll find a lot of maximums and minimums. You find the highest point or the lowest point. Where is the highest point of this graph going to occur between what two numbers? Between 0 and 2. The max is somewhere here between 0 and 2. You know right away without doing anything, just because you have a feel of the rough general look of the graph. You know quite a bit about that graph. He's only positive between 0 and 2. Everywhere else he's negative, you know. His highest value is between 0 and 2. Good information. That quick. Good? Are we happy about that? Questions on that one? Remember that stuff? All right. Let's go to, what are we on? Exam 2A part 1. So continuing with 2A part 1. Oh, there's so much I could do. I could do horizontal. How much time do we have? Yeah, I'm gonna leave that. You can look that up. How about number 7 to be valuable? F of x equals 3 minus 1 over x plus 4 squared. And they want a graph. they want, you know, same old stuff. Central point, some other point, you know, all that usual kind of stuff. So give it a try, see what you remember from that one. So one thing you got to remember, this is like, you know, identification thing I'm talking about, is you got to remember what is 1 over, what is the graph of 1 over, when x is in the denominator of a fraction like that, what does that look like? 1 over x. Anybody remember that one? Yeah, 2 branches with the crosshairs. Remember, that's the one I'm being violent. It's guns, it's crosshairs, so whatever helps you remember. So it's the 2 branches with the crosshairs. The diagonal, the 2 asymptote lines, right? 2 asymptote lines, the crosshairs, and we got the 2 branches. Remember that one? So you want to know that one. Put that on your study sheet for the final. But then there's also 1 over x squared. How's that? That also has the crosshairs, the 2 asymptote lines. But where are the branches for 1 over x squared? They're actually both up because x squared is positive, huh? Or they could be both down if you have a negative in front of that. Whatever they are, they're side by side instead of diagonal. So you want to have these 2 things on your study sheet for the final. So now, with that in mind, as you look at this one, you're going to go, oh, okay, that's a 1 over x squared, basically. So it's going to be like this one. So I got to find the crosshairs. I got to find where those vertical and horizontal asymptotes cross. And then I'm going to put 2 branches side by side, because it's basically 1 over x squared. So all that's got to occur to you, because it's on your sheet or whatever, you know, identification. That's the first thing, and then you dive into the details. So how do we do the details? So the details, we make our XY chart, and we find the center point and one other point. So how do we find the center point? Let me let you do that. Some valuable, important lessons there. Right. So that means something particular. Yeah, right. Good. Good, Terrence. It's all coming back for you, huh? You weren't sleeping during that lecture. So remember how do we find the center point on any of these graphs? On any of these graphs, how do we find the center point? Whatever makes the x zone equal 0. So what can you plug in here to make that zone, x plus 4, be 0? It's negative 4, huh? We good so far? Negative 4? Plug in negative 4 for x. You always plug in whatever will make the x zone 0. So negative 4 makes the x zone 0. So when you do that, you get y equals f equals y equals, same thing. 3 over 1 minus 0, basically. Is that okay? Squared is just 0. What's that? What's 0 in the bottom of a fraction? This part is undefined, right? Error on your calculator, 1 divided by 0, error on your calculator. What does that mean, though, about a graph? You remember? What does it mean in an undefined spot on a graph? Vertical asymptote sits there. That's what it means. So when you get undefined in an equation, the picture has a vertical there. That's why it's undefined. You can't touch a vertical asymptote, right? You can touch a horizontal, but you can't touch a vertical. So you can't touch a vertical asymptote. So that's what that means. Now, remember I gave you the trick. I said just pretend the undefined part is 0. That'll help you find the values you need. So it's like it's 3 minus 0. It's really 3 minus undefined. So it's technically undefined. But pretend it's 0, and then you'll get your spot. Negative 4, 3, what spot? That'll be the center of the crosshairs. That's exactly. You still, even though it is undefined, it's not really a point in the graph. It is where the two asymptote lines cross. It's a helpful point for us to complete our graph. It is where the vertical asymptote and horizontal asymptote meet. So let's do that. So back 4, up 3. Right there. In fact, I need more room. Let me move that graph over. Right there. Back 4, up 3. There's the center of the crosshairs. There it is. All right, we good so far? Does that make sense? Remembering all this? And now, how do we find the other point? What do we always do to find that we got the center point? We always add 1, huh? We always add 1 to whatever your center point was. So negative 4, add 1 is negative 3. All right, so plug in negative 3. You get 3 minus 1 over negative 3 plus 4 squared. 3 minus 1 over 1 squared. 3 minus 1, 2. So back 3 up 2 right there. Back 3 up 2. Dots right there. So, all right, let me let you finish the graph. Can you finish the graph from there now? Back 3 up 2. We got our dot. We've only got one dot, but that's enough with the knowledge we have of the graph. Can you finish from there? Where does it go? Well, one branch must be here. All right, that's what that dot is telling us, is the quadrant of the graph, right? And it hits those asymptote lines. And then where's the other one? Where's the other branch? Is it diagonal or side by side? Yeah, because of the x squared, it's side by side. They're both down, actually, because it's actually a negative in front. That's what makes them go down. And there we go. We got the graph. So you know a lot about that graph. You know, for example, it never gets above 3. The height never gets above 3, does it? Is that good? Questions on that? All right. 2A, part 2. So number 1. I don't know. I don't know if I want to do number 1. I'm going to skip number 1. I mean, number 1's hard and important. I just don't have time for everything. Look back at the old reviews and stuff. Let's do what? There's so much to do. So little time. How about number 4? How about 4 to the x is 8 to the 1 minus 2x? Let's just solve for x. So solve for x. So identification, what jumps off the page? What's special about this one? Exponential again. X is in power, right? So what does that mean when x is in power? we got to do something, right? There's a couple of ways you could go. I don't know, method number, I don't care how you do it, method number one is you can make bases the same. That doesn't always work though, but you could on this one. 4 can be made 2 to the 2. 8 is 2 to the 3, right? You can make them both out of 2's. See what I did there? 4 is 2 to the 2, 8 is 2 to the 3. Once you make the bases the same, you can set the powers equal. You can say, oh, okay, this power equals that power then. So 2x is 3 times 1 minus 2x. See that? Once you make the bases the same, you can just set the powers equal. And you get 2x is 3 minus 6x. Add the 6x to both sides. 8x is 3 divided by 8. There it is. 3/8. Or the other way. What's the other way? You could do natural logs. Do you remember that? You could do ln on both sides. Because natural log is what will bring powers down. That's the way you have to do it. What if they, instead of an 8, what if they'd made this a 7? Then there's no way I could have made the bases the same, right? And you'd have to do natural. So natural log's the real deal. That make the 2's thing, that's a cute little silly method that works every now and then. But real life, building bridges and doing things with math in the real world, natural log is what lets powers come down. That's the real deal, and you'll definitely have to do that at some point on the test. So you'd bring down. In fact, let's do it on one where we have to do it. How about that? Rather than just redoing it. This was the easier. Whoops, I just erased it. This was the easier way. 3/8 on that. So let's go to a new one. If you got that one down, is it okay if I flash off of that one? Okay. So let me give you a new one. This is exam 2A part 2 still. And I'm going to give you what? Number 5. E to the 4x is 2. So there you go. You're going to have to get that x out of power. You're going to have to, so x in power, exponential, L in both sides. So that's what you need to know. X in power, L in both sides. So L in both sides, like that. Remember that. And then, what does that allow this power to do? Come down to the front. We've seen that a million times, huh? That's the great quality of natural logs, right? They let powers come down to the front. And what's the ln of e? This is 1, so it's 4x is ln 2, divided by 4, there it is. Good on that? So we got x in the power zone, ln brings it down. ln takes it out of power. So, be aware of that. I'm going to move on. You okay with that? Okay, let's try. Oh, there's just so much to do. I'd like to get to exam 3, some of that parabola stuff. Yeah, so why don't I just do one of the really important ones? Well, they always all look important to me. So, and then I end up not getting to stuff. So exam 2A, part 2 still. How about number 8, which says 2 plus 8 ln x equals 11. Can you solve for x there? So let's subtract 2 from both sides, like that. Divide by the 8. Everybody good to there? Now what? What do we do to get rid of that ln? So x can be alone and we can finish this problem. Remember, you do the e to both sides. I'm putting that e low down. It's not on the level, it's low down because it's e to the ln x power. And e to the 9/8 power. And there it is. To e with both sides. Remember that? So you need a review to bring all that back to your memory banks. All right, is that good? Can I flash off of that? Got that one down?
You can't go any further with that, right? That's the answer.
Yeah, they might want a decimal. If they want a decimal, just hit the buttons on your calculator. 3.08, my notes say. So there we go. All right, let's try exam 2, part 2A, part 2, number 11. This is definitely one that would be good to see. All right, so let's do number 12. Yeah, 12 is a good one. So number 12, x cubed minus 5x squared greater than 36x. All right, can you solve that thing? Just says solve. So how do you solve? Something has to jump off the board again. You know, I'm trying to do that identification thing with you. What is special? What is different about this problem that is in basically no other problems? What's his unique mark? Yeah, the inequality. The greater than, less than. The greater than, less than needs to jump off the board for you. You got to look at this and say, oh, yeah, greater than, less than. What does that mean? Well, that means greater than, less than. Number one, get a 0, factor. Excuse me. And step 3, going to go to the number line. Remember the number line? You go like true, false, true, and that kind of thing. Remember that? Or false, true, false, or whatever it may be. Remember that you got to do number line eventually, and you're going to have shading and sections. All that's got to occur to you. Generally, that's the plan when you see greater than, less than. All right, so let's try that. So you bring that 36x over, then you factor, take out the x, like that. Isn't that good? And then factor what we got. What multiplies to be 36 and can add to be minus how? What times what's 36? 4 and 9. Sign in the middle goes in the bigger, right? Sign in the middle is negative. Always goes to the bigger of the two. So there we go. And then you set, well then, what are the zeros there? 0, -4, +9. Those are the three things that make that 0, right? So if you go to the number line now, kind of like the in behavior, you know, up and down kind of thing. We do that again. So let's do that. So we've got 0, -4, and +9. All right, so what's the end behavior? What's that? Yeah, the end behavior on this one is positive, right? But you can even see right here, look, there's a leading term. It has been multiplied out. It's positive. The end behavior is going up. the end is positive x cubed. It's going up. Remember all this kind of stuff? And then each of those dots, is it going to bounce or is it going to pass through? Remember, it's all about the power. First power, first power, first power. They're all odd powers. They're all going to pass through, pass through, pass through, pass through, pass through, pass through. Good like that. No even powers. No bouncers on anything there. Just all passers through. So we got a rough graph here. So now we should be able to answer the question. How do we answer the question? Yeah, greater than 0. Where is it greater than 0? Here and here. Those are the two parts that are greater than 0. So on the x-axis, that'd be between -4 and 0 and 9 on to infinity, huh? See, those are the two places where the function is greater than 0. So the answer then would be -4 comma 0 comma 9 to infinity on that. Are we good? So greater than, less than, everybody always misses it. That's an exaggeration. But 70% of the class, it's usually that high, misses the question. And the main thing is they're just not identifying. What I mean is, here's what I see all the time, guys. Just so maybe if I say it, it'll help you to not do it. This is what maybe I'm exaggerating. 60%. It's more than half. Usually more than half of the class, 60 to 70%, will do a good job. They'll get all the way to here. You know, they'll factor the thing. They'll do a good job factoring. They'll get their 0. They'll factor. They'll get to there like that, right? They'll get to here like this, and then they'll go, okay, greater than 0, greater than 0, greater than 0. So that one's done. Greater than -4, greater than 9. There's my answer. Done. Wrong. Completely wrong. I just can't give anything for that. That's just a 0. Because you're missing the complete concept. I know you can move x's around, but you're missing the complete concept that this is something going up and down on a number line. It's a graph, right? I would say, what does that even mean? Like, that just disturbs me logically, that kind of answer. I'm just like, is anything going on? Is anything going on? I mean, like that answer, what does that even mean? X is bigger than 0, and it's bigger than -4, and it's bigger than 9. Hold on. Just think real life. If I say to you, hey, I'm going to give you some dollars right now. I'm going to give you some dollars. I'm going to give you more than $1, and I'm going to give you more than $5. The amount of money I'm going to hand you is going to be amount of money more than $1, and I also want you to know it's going to be more than $5. Well, then why did I even tell you more than $1? If it's more than 5, it's more than 1. See what I'm saying? Well, what does that even mean? It's bigger than 0, and it's bigger than -4, and it's bigger than 9. Well, just say it's bigger than 9. And it is bigger than 0. And I mean, that person's just not even thinking about what this even means, right? Do you see that? Do you see the total illogicalness of that statement? You want to stay logical with math. You want to stay in reality. You want to remember, like, what's happening here? What is this even about? That person does not have a clue. They're just moving things around. Monkey see, monkey do. Right? You don't want to do math that way. I'm not trying to be rude or anything, but I'm saying this is math science. If you want to go forward and get some kind of a degree in math science, you got to pursue not monkey see, monkey do work. Don't just move things around. Think about what they really are. Right? That's just not, if you think for a second, that's just nonsense. That can't be the answer, right? So instead, you come down to here and you say, okay, and that's why you got to realize the greater than, less than means number line, true, false, true kind of thing, or greater than, less than. I called it true, false, true. So it means these two sections on the number line. Does that make sense? So you got to go to the number line. So remember, on the greater than, less than, got to go to the number line on those. Is that good? Are we good with that? All right, so let's go to exam 3. We have less than half an hour. Should we do that? Tried to do the hardest ones from exam 2. Let's go to exam 3. That was a hard one. right? That was parabola, hyperbola, ellipse, all that stuff. That's the hardest for me, personally, to remember. Every time I teach this class, I have to remember again those particular formulas, because I have a bad memory. All right. So, exam 3A, part 1. Exam 3A, part 1. Let me see, which one should we do? The parabolas are always... Here's question 4. X minus 2 squared is minus 8 y plus 2. They want you to graph it. Graph it. And tell them the vertex. They want the vertex. And they want, like right here, and they want the focus. And they want the directrix. Directrix. Do you remember any of this? It's hard. It'd be hard for me if I was in your shoes. This was always hard for me to remember. These are very particular. This one's a parabola. Do you remember? How do we know it's a parabola? Maybe we should talk about that first off. How do you know, like, the parabola from the hyperbola from the ellipse? What unique mark makes this one? Well, they're asking for a directrix line. That's an indicator, right? Only the parabola has a directrix line. But what unique mark makes you know this is a parabola? About the equation, I mean. Remember, for parabola, you have x squared and y to the first power, or y squared and x to the first power. Remember, for parabola, only one of the letters is squared and not the other one? Whereas the other two, ellipse and hyperbola, they have both letters squared. So you see how we have x being squared here, but y is not? It's just first power up there. No power showing, first power. So that's the mark. So you look at that and you go, oh, it's a parabola for sure. Because one letter is squared, the other is not. So you go, okay, it's a parabola. I know it's a parabola right away. And what do I always have to do with a parabola? Do you remember? You must get a 4 on one side. You've got to force a 4 to show up. So remember, I gave you the... I keep saying remember. You probably don't. I wouldn't. This would be the stuff I would for sure put on my study sheet for the final, because it's hard to remember all this stuff. I, even as the teacher, have to remind myself every time I teach it what it all is. So it's y squared is plus 4ax. That goes to the right. And then y squared is minus 4ax. That goes to the left. I definitely put that on my sheet for the final. And then x squared is plus 4ay, goes up, and x squared is minus 4ay, goes down. Remember, it's all about the first power letter. What direction the first power? So x to the first power, positive, is right, because that's the positive x-axis. This one's the negative x-axis. This one's the positive y. This one's the negative y, right? It's all about that first power letter, whether it's positive or negative, x or y, that tells you the direction. Parabola is hard. There's a lot to parabolas. We spent a couple days, like 4 hours, I think, 3.5 hours talking about parabolas. And you could watch all those lectures again. I'm sure that's what you plan to do with all your hours. But do what you need to do anyway. All right, so so that means I need to take this equation they're giving me up here. We get a little room. And get a 4 to come out. So I've got to get a 4 to come out. How do I do that? You got to take that minus 8 and make it 4 times minus 2. Or you can put the minus 2 in the front. It doesn't matter. Whatever. But you got to force a 4, huh? Because when you forced a 4, the other thing is called your A. See the A in each of the formulas? It's the number next to the 4. So that's still negative 8. Negative 2 times 4 is still negative 8. You just factor out a 4. You factor out a 4. That other number is your A. And that tells you how far to the focus point. Remember that? That's what that A tells you. So now we're ready to graph. Is this one going up, down, right, or left? Where's this? Which direction is this parabola going in? Yeah, because it's negative y to the first. So it's going down. So this is a parabola headed down. Let me erase all this stuff that hopefully you'll put on your sheet. So this parabola is going down. Where? Oh, what's the center? I didn't even think about that. What's the center of this parabola? Remember how we do center? Opposite. Opposite. Opposite of minus 2 plus 2. Opposite of plus 2 minus 2. Right, opposite, opposite. So right 2 down 2, right there is the center. Like that. That's the center. And we already said it's going what? Negative y. So it's going down. So it's right there at over 2, down 2, headed down. And then they're asking us for the focus point. So let's find the focus point. So where's the focus point? Down 2. It's always inside 1, 2. So it's down at negative 4, over 2, down 4. It's always inside the U shape. Focus is over 2, down 4. See that A value told us where the focus point is. It's a lot of really little details, isn't there, on these? That's why I think these are so painful. To me, this is the hardest part of the course, is all this picky little details of parabola, especially parabolas, because they can go 4 different directions and all that stuff. And remember the Directrix line? It feels like taking anatomy, or I never took anatomy, but those classes scare me where you got to memorize a million little facts. That's what parabola feels like. There's a million little things. So Directrix line, where's the Directrix line? It's always the opposite direction from the parabola. It's behind the thing. So if it was from the center, I just messed everything up. From the center to there, then you go back to, there's going to be the Directrix, and it's a line actually, but it'll be here. A lot of people, most people gave me the point. That's fine. I gave you credit. I don't care. If you give me the 0.20, it's technically the line x equals 0, but I'm fine with either one. At either point, I know you know where it's at. Either way, it's good as long as I can tell you know where the thing's at. Technically, it's x equals 0. It's the line x equals 0. Y equals 0. That's y equals 0. What am I doing? Y equals 0. It's technically the line y equals 0. But I'm fine with the 0.20. That makes sense? So the focus point and the Directrix are same distance 2 different ways from the center, aren't they? So there we go. I think that's everything they wanted, right? Yeah, we got it. Oh, and the vertex is the center. That's here. Yeah. We got it. Vertex means center. They call that vertex. I just call it center, but they call it vertex. All right, you remember some of that? It's going to take a little, would for me, if I was taking this final and not teaching it every day, I would need to review that stuff because it's a lot of little details. Questions I can answer on that one? Does that make sense? All right, so do you want to do, we could do one of those hyperbolas or ellipses where you got to, oh, how about one of those word problems? Well, those are always hard. Well, there's just so much stuff. There's always so much stuff. We could, yeah, I could go over that again. Probably not like, there's probably not one like that on the final. I don't know. I don't remember exactly what's on the final. I might give you completing the square. Remember those? I don't know. I'm just grasping at straws here. I don't exactly remember. What was on part 2? Oh, part 2 was that other stuff. Yeah, maybe that'd be valuable. Well, okay, hold on. I keep changing my mind. Let's do one of those where we got to complete the square. Where's one of those complete the square ones? Oh, it's parabola. That's why I don't want to mess with it. So I already did a parabola one. Yeah. All right. I don't want to do that. I don't think that's valuable. So let's. Maybe it is. All right. Sorry, I just keep changing my mind. We'll do it. Let's see. So here it is. This is 3A. Part 1. And question number 7. Y squared plus 10y equals 8x plus 23. You got to complete the square. Whenever you have y squared and y to the first, or x squared and x first, you must complete the square. Remember that whole completing the square thing? Remember half the middle term? How about I just do it real quick, and then we'll go on to part 2 and do a couple there. So you just grab that middle, and you put it over 2, and you square it, which is 5 squared, 25. Remember that? I call it the magic number. Then you add 25 to both sides. Because you've got to make that left side factor. You don't want y squared and then like regular y. You want them to factor. So, let's come back here. So I'm going to add 25 to this side and add 25 to that side. Everybody see how I found that out? You take the middle term, put it over 2, square it. So y squared plus 10y plus 25 is 8x plus, what's that, 48? And then factor. This factors as the same thing twice. Well, and so the other side factors also, huh? And so that's y plus 5 squared. And the other side you got to take out a 2. Remember how we always take out a 2? I'll go dot, dot, dot from there. Is that good? You remember some of that? Completing the square? We've done a lot of stuff in here, haven't we? We've done a lot of material. So, is that okay? Questions I can answer on that? You guys are always my quietest group. I have another section of pre-calculus and then an online section. You guys are always my quietest group, but I think you're also my highest scoring group. Yeah, I think you are. So maybe you're just quiet because you already know it. You're good. Questions I can answer? Is that okay? So then you would just do the rest would be just like we did on the last one. You know. So it's all about adding that number over, middle over 2 squared to both sides and then factoring. Basically. All right. Let's go to part 2. Do a couple there. We had those kinds that where we had well, let me show you. So exam 3A part 2. 3A part 2. Yeah, like yeah, that's hard. They just keep saying that, huh? How long? Oh, by the way, I'll give you all the formulas in the top of the final that I gave you on any of the exams. So the PERT, remember that one? The A is PERT. The PERT, the other one, P, 1 plus R over N to the NT. Did I give you any other formulas? Whatever was on the top of any of the exams will be at the top of the final. They're all there. I think that might be it. That's all I ever put, I think. Anyway, feel free to look back at them. I don't see any other formulas. So those will be at the top of the final. How long for an investment to triple? How long for an investment to triple at 10.5% compounded continuously? How long for an investment to triple at 10.5% compounded continuously? Why don't we wrap up with this problem, and then I'll hang out if you have personal questions, things I can answer. I'll hang around to do that for you. Let's just try this one, and we'll stop. All the reviews out there anyway on the YouTubes for you to see. Which formula are we going to use? The PERT or the other one? The PERT, yeah, the PERT is for the continuous. So it's this one. It's whenever it's continuous compounding instead of like monthly, weekly, yearly, all the different versions. The continuous is for the PERT. This other one is for, monthly or biannually or semi-annually. That's how they usually say it. Same thing, yeah. Semi-annually or annually or whatever. Daily, and then there's one quarterly. Any of those is the other one, right? So Continuously is the PERT, so we use the PERT. So use the PERT formula. And what am I going to put in? Well, for something to triple, what do you want the amount, the A, to become for tripling? 3p. Yeah, not just 3, but 3p. Is everybody good with that? And the rate is the, got to move the decimal back 2 places, 0.105 t. See how the amount became 3 times the principal? And then you just divide off the principal on both sides. So you get 3 equals e to the 0.105 t. So far, so good. Divide off that p on both sides. How do you solve for t now? Yeah, because t's in power, right? That's where that recognition, when letter comes into power, ln. Yeah, so now bring it over here. Now you ln both sides, exactly. We'll have a few of those, right? That came up a couple times. Ln of both sides. And then the whole power comes down. Like that. ln e, that's just 1. So ln 3 is 0.105 t. And then divide, last step. Divide by 0.105. There it is, calculator, whatever. ln 3 over 0.105 on that. Does that make sense? Questions I can answer? All right, well, hang out. I'd be glad to answer particular questions off the test we just took.